Welcome back to Aurora Tech Channel. Today, I will test out a Kickstarter 3D printer, not just another Kickstarter project, but the one that has broken every record so far in terms of both funding and backers. Let's take a quick look at some of the biggest 3D printer campaigns on Kickstarter. Starting with number 5, back in 2012, when I was 3 years old and hadn't started 3D printing yet, it was the Formlabs Form 1. It's a mid-$2,000 resin printer that had over 2,000 backers and raised almost $3 million. Number 4 is the Creality CR6 SE in 2020. By then, I had already started 3D printing, and I also tested that machine. It had over 10,000 backers and raised $4.3 million. Number 3 is the Bambu Lab X1. I've also tested that machine, and it was a real breakthrough in the 3D printing industry. Even now, 3 years later, many companies are still struggling or only just releasing something similar. That project had over 5,000 backers and raised more than $7 million. Number 2 is the Engravers 5. This project launched a few weeks earlier than the Bambu Lab X1 in the same year. It had over 11,000 backers and raised $8.8 million. And number 1 is the machine we'll test today, the SnapMaker U1. With almost 4 weeks still left in the campaign, it has already raised more than $14 million and has over 15,000 backers. So let's take a look and see why so many people are supporting this project. In the 3D printer market, when it comes to multiple toolhead auto tool changing machines, we don't have many options. Excluding DIY solutions, the only true consumer grade, ready-to-use option has been the Prusa XL, which cost over $4,000 for the assembled 5 toolhead version. The SnapMaker U1 uses a similar setup, but makes this 4 toolhead tool changer available at a fraction of the price, just $799. That's not much more than a Prusa single to dual toolhead upgrade kit, or even the Prusa XL enclosure. The price advantage is obvious. Beyond that, SnapMaker seems to have studied all the major advanced consumer 3D printers in depth and combined many of their best features into this one machine. The print volume is 270 by 270 by 270 millimeters. The table space required is about 24 inches, 600 millimeters, by 20 inches, 500 millimeters, with a height clearance of about 30 inches, 730 millimeters, to allow for the Bowden tubes and cables on top. The machine weighs 40 pounds, or 18 kilograms. It's half enclosed. The enclosure is plastic, and the top cover isn't included by default. The Kickstarter price for the cover is $149. The machine only comes in one configuration, which includes all 4 tool heads. It uses rods and magnets so the carriage can pick up and release the tool heads, similar to the Prusa XL. It's undeniably inspired by Prusa, but the build is more refined. The tool head housing is injection molded, the cabling is simplified into a single USB-C CAN bus connection, and the thicker Bowden tubes hold their shape better. The motion system is Core XY, with carbon rods on the X-axis like the Bambu Lab X1, and linear rods on the Y-axis. The Z-axis is supported by 3 rods and lead screws. Since you need to mount 4 spools, it uses 4 spool holders similar to those on the Bambu Lab A1. One special feature is the filament feeders. They work like the Ultimaker design, pushing the filament all the way in, so you don't have to feed it manually through a long tube like on the Prusa XL. The maximum nozzle temperature is 300 degrees Celsius. The printer comes with stainless steel nozzles by default, and you can order another set of 4 hot ends with hardened steel nozzles for $49. The bed temperature goes up to 100 degrees Celsius, and the print surface is a double-sided textured PEI sheet, which is a bit thicker than most others on the market. The touchscreen is 3.5 inches, and it comes with LED lighting and a built-in Full HD camera. The firmware runs on Clipper, and you can access the Fluid Web interface if you don't want to use their cloud service. For this test, I will only use the printer on my local network. The slicer is a customized version of Orca Slicer, since this machine is currently one of a kind, and the standard Orca Slicer doesn't yet have a profile for it. Hopefully SnapMaker will submit one in the near future. I would like to thank SnapMaker for sending us this machine to review and for sponsoring today's video. As always, we won't hold back from pointing out the cons and unfinished features that we find in this beta unit. With that, let's get started. As a multiple toolhead machine, the box is smaller than I expected. Everything is packed inside a large bag, and accessories and parts are packed inside the machine. Besides the machine, we have the user manual and a separate box. Inside, there are some better quality tools, Bowden tubes, filament feeders, spool holders, a filament residue tray, some spare nozzle wipers, and there are also 4 tool heads underneath. Setting up this machine is quite simple. The first thing is to remove all the protective materials and screws that secure the bed for shipping. Then we can snap the filament feeders on the side, just connect one cable and snap it on. Do the same on the other side, so we have 4 filament insertion points. Connect 4 smaller diameter Bowden tubes from the machine to the filament feeders, and also snap 4 spool holders on the side. This is similar to those on the Bambu Lab A1 series. Then hang the filament residue tray right under the tool head wipers, and then we will mount the tool heads on the machine. You should hear the snappy click sound once the tool head is securely attached. Then connect the larger diameter Bowden tube from the machine to the tool heads and connect the cables. That's all we need to do, so we can now turn on the machine. Select language, followed by location. If you don't use their cloud service, it shouldn't really matter. Next, agree to the whatever it said screen, then connect the printer to your local Wi-Fi. I can only see 2.4 GHz networks from the screen, so I assume 5 GHz is not supported. After entering the password, if you can see an IP address here, it should be good. For the phone app, you need to register an account for their cloud service, but I'll skip this part as I generally just use most 3D printers within my local network. Next, it's going to start calibration, and it's going to take over 30 minutes. First, it will try to attach each tool head to make sure they were installed correctly. Then, we will remove the print surface, and the machine will do the XYZ offset automatically by probing the nozzle on this metal cap so it can find out the offset between 4 tool heads on all axes. Then, it will start an 11 by 11, 121-point auto bed leveling. After that, it will calibrate input shaper. The calibration is now done, and it will show the filament loading screen. As this machine uses the Bambu Lab A1 style spool holder, not every brand is going to fit. It can fit with the Chitu Silk PLA, which you often see I use in my test. Once the filament is inserted, it will feed automatically. For some spools like the Prusa filament, the hole on the spool is too small so they don't fit, but another of my regularly used filaments, Eryone, fits just fine. The VOXELPLA Pro also fits well, and I will just feed 2 random colors on the right side. Since I am using third-party filaments, I have to enter the filament type and color on the screen. I will just select everything as basic PLA and choose the corresponding colors. Do the same to all 4 spools. Now we can start our first print. I will start with slicing a 4-color Benji to make sure the multiple tool heads are all working normally. I just divide the Benji into a few sections and print with different colors. The estimated printing time is about 42 minutes, which is pretty good. As a normal Benji with the slicer default profile of other new-gen printers, to print a single color Benji is about 30 minutes. As there is no filament poop like an AMS-style machine, the only material wasted is the small prime tower, which weighs less than 4 grams. Let's take a look at the speed of the default profile. The max speed is set to 300 millimeters per second, which is in line with other single-color printers. The maximum acceleration is set to 10K, which also looks normal. I will then send it to the printer. The color in the slicer will match the color of the filament loaded. If not, you can always change to the closest color for substitution. I will not do flow calibration as I am using a few different brand filaments, but most preset PLA flow should work pretty well. Of course, I will not do the 121-point leveling again, so I will just turn on time-lapse. The file is small. The upload seems pretty fast. It then switches to the device tab, and you can see the printer start moving. It grabbed the first tool head and waited for the temperature to heat up and start. It's going to start with the blue-purple-black tricolor filament. After the first section is done, it's going to change to the second tool head. From what I can see, the tool head change is pretty fast, almost as fast as the Prusa XL. I will compare this part later. After a while, it changed to the third tool head. It will do 2 more color changes to finish the print. The printer screen didn't show the time, but since it uses the fluid web interface, I can see the time is 47 minutes and 2 seconds, so it took about 5 minutes for the prep time. The print is decent, and the surface is fairly clean. The cooling at the front also looks good. The top is also finished nicely with no stringing at all, so I assume everything is working normally. As I want to test out the multiple tool head capability of this machine, instead of starting with my benchmark tests, I will start with printing multiple colors and multiple materials. I will start with my Hello Kitty army. The estimated time is about 8 hours, but I don't think the estimate is very accurate since there's no way the prep time is only 19 seconds. Compared to the Prusa XL 5 toolhead machine, the Prusa XL estimated time is 9.5 hours. The U1 is about 15% faster, as the single print head printing speed of the Prusa XL is slower, but the tool changing is slightly faster. Compared to a single print head AMS machine, like the X1 Carbon, it will take almost 15 hours, so the U1 is about 45% faster. When printing 4 together, the advantage of a multiple toolhead machine is not huge, but if we just print one model at a time, the SnapMaker U1 is going to take 3 hours, while the Prusa XL is 3 hours 18 minutes, which is similar. However, the X1 Carbon will take close to 10 hours, which is 3 times slower. I will still print 4 at a time in order to test the stability of printing multiple objects on the same plate. Let's do a sound test. Since this printer doesn't come with the optional top cover, the noise level stays around the low 50s most of the time, but during rapid movements, it may jump to the high 50s. The print finished in 8 hours 20 minutes, about 20 minutes longer, but not too far from the estimated time. All kitties were printed very nicely. The color transition using multiple tool heads is very clean. There is also minimal waste. The filament wasted is just about 20 grams for the wipe tower. Unlike AMS-style machines, the filament wasted there is often more than the model itself. Next, I will print a 4-color Vegeta. Unlike AMS-style machines that allow me to link up to 16 colors or more to print multiple cyan statuses, I will only print a single Vegeta in Super Cyan status, which is good enough for a 4-color machine. The estimated time for this model is 2 hours and 28 minutes. For the Prusa XL, the estimated time is 2 hours 37 minutes, which is basically the same. For the X1 Carbon, a single toolhead AMS requires almost 8 hours, while the H2D with 2 extruders is a little over 6 hours. So, multiple toolheads like the U1 and Prusa XL have a huge advantage for this type of multicolor print. Let's time the toolhead changing process. From the last color stopping to the new color starting, the first time it takes about 8 seconds. I timed it again, and this time it takes about 6.8 seconds. Sometimes, there is a short delay of 1 to 3 seconds, mainly because the layer time of this tiny model is too short and doesn't give enough time for the next tool head to heat up. The print finished in 2 hours 36 minutes, about 9 minutes longer than the estimated time. After the support was removed, the print looks really good. It's better than any AMS-style single toolhead print, which has a chance for color contamination, especially when switching between light and dark colors. The back is also printed beautifully. Next, I will try a more challenging print, a retractable master sword. This 4-color model is going to have an excessive number of color changes. As you can see, it will perform over 1,700 color changes, so it will be a good test of the reliability of the tool changer. On the Prusa XL, the time is a little faster due to slightly quicker tool changing, but the difference is minimal. However, on the X1 Carbon, a print with the same 1,750 color changes will take over 2 days, or 51.5 hours, which is almost 4 times longer. Even with the H2D with dual extruders, it's almost 38 hours due to fewer color changes, since we can put the blue color on the left extruder. Okay, let's go back to the SnapMaker U1 and see if it can really print this in around 13.5 hours. This time, we can see some random delays of about 3 seconds on some color changes, bringing the time up to about 8 seconds. After that, another change took about 6 seconds, so I would say most of the toolhead changes are around 6 seconds, with occasional ones taking about 8 seconds. This time, the print finished in 13 hours 38 minutes, closely matching the estimated 13 hours 35 minutes. The sword was printed well, and all the color transitions are clean. After removing the support, it looks beautiful. But the most important part is it functional? Yes, it is. However, the sword didn't extend as far as the design intended, as I found some minor layer shifts inside the blade. Not serious, but I will send this model to SnapMaker so they can investigate for future improvements. After testing a few multicolor models, I will now try some prints with multi-materials. I will print a horse model with PETG and use PLA as support instead of using expensive special support materials. This method was introduced to me by my friend Mickey from Australia. How are you, Mickey? Since PETG and PLA won't stick together, I increased the brim size of the prime tower and set the walls of the tower to PLA only, hoping it would hold up better. The print finished in 5 hours 54 minutes, about 11 minutes longer than the estimated time. As expected, the PETG model easily detached from the PLA support. It printed just as well as with more expensive support materials, and the overhanging part came out super clean. This is a pretty awesome model, and I have no complaints. As PETG and PLA don't stick together, they work really well as support materials for each other. Next, I'm going to print a PETG Jeep with TPU. So the Jeep body will be printed in PETG and the tires will be printed in TPU. I did notice some stringing on the TPU. That's expected, since printing multiple parts with TPU can cause more stringing when the nozzle travels longer distances compared to just printing a single part. When switching tool heads between materials with different printing temperatures, I notice a slight delay of a few seconds, bringing the total tool change time to around 12 seconds. This print finished in 4 hours and 40 minutes, about 15 minutes longer than the estimate. The strings between the TPU wheels were easy to remove, and while the humidity in my camera cabinet is around 20%, a little extra drying could help even more. Overall, the result is really good. The wheels are nice and bouncy, and it's just a cool print that mixes two different materials. Now let's go over my benchmark test prints and see if there are any surprises. First, the number slider for clearance. It printed smoothly in about 2.5 hours, which is average. The quality is good, no stringing on the top, and the bottom has solid clearance. It works as expected. Next, the retraction test. The extruder is able to push out a tiny bit of filament and retract immediately. Both the print time and quality are in line with other high-performing printers. The only issue is at the bottom. The tiny patterns are not perfect. Some of them were squeezed a bit too low. For the tolerance model, it printed about 8 minutes faster than average. On the square side, it couldn't clear the 0.075mm or the 0.05mm gaps, but on the cylinder side, it cleared down to 0.05mm and stopped at 0, which is perfect. That tells me the flow calibration is solid, but the pressure advance may need more tweaking. On the surface quality test with the Robo Alpaka, it performed really well. It's not as fast as the ultra-high-speed printers, but it still printed fairly quickly, about 30 minutes faster than the average 4.5 hours. The surface quality is excellent. Let's take a look from all 4 angles. Then, we will compare it to those printed by other latest generation machines. Compared with the Prusa Core 1, the U1 is faster and just slightly better in surface quality. Compared with the Prusa XL, the XL has the better surface, but the U1 is much faster. Against the Bambu Lab H2D, which has average print times, the U1 is faster, though the H2D surface looks a little better. Compared with a fast machine like the Creality K2+, the K2+ is indeed faster, but the U1 has the edge in surface quality. Finally, the PLA sheet test for AutoZ offset and leveling accuracy. Some areas were squeezed a bit too low, but the sheet did peel off in one piece. This first layer isn't perfect, but should be good enough for almost any prints. Let's talk about the pros and cons of this machine, starting with the pros. 1. The toolhead switching works very well, on par with the Prusa XL, if not better. The only real issue I had was with the Multicolor Master Sword, one of the toughest models I've ever tested. The model printed successfully and was functional, though it had some minor layer shifting. To be fair, I couldn't complete this on the XL either, which showed even more shifting. I've included the model link in the description if you'd like to try it yourself. Aside from that, all other multicolor and multi-material prints completed without problems. The U1 clearly draws inspiration from the Prusa XL and other strong machines, but with SnapMaker's refinements, it stands out as a reliable platform. 2. The printer isn't heavy, but it feels very sturdy on the table, and I don't see any issues with stability when printing at high speed. In terms of speed, it's not as fast as the ultra-high-speed machines like the FL Sun Delta series or the Creality K2+, but it is still slightly faster than most printers in the market. 3. The toolhead offset calibration is similar to the Prusa XL, but more refined. The gauge is built into the heated bed, so there's no need to screw it on and remove it afterward, which also avoids the chance of losing it. The offset alignment was excellent. I only calibrated it once and was able to complete all the tests without any issues. 4. In terms of value, the SnapMaker U1 is insane. For $799, getting a 4-toolhead machine is almost unheard of. When a single toolhead for the Prusa XL costs close to $600, or nearly the same amount just for the XL enclosure, you can get the entire U1 instead. Even with the extra $150 for the top cover, the price is still insane. Since this is a beta machine with some unfinished features, which SnapMaker had already told me about, it is what it is. Most of these issues will very likely be resolved, but for now, I can only base my review on the machine I received, and I can't assume everything will be 100% fixed in the future. So now for the cons. 1. This machine takes clear influence from the Prusa XL, Bambu Lab X1, A1, as well as the Ultimaker S3, and some others I don't have. It incorporates many great features, but also carries over some disadvantages. For example, on the X1, the carbon rod is not replaceable. You have to replace the entire assembly, and I'm concerned this may also be the case with the SnapMaker U1. 2. The glass door cannot fully open, just like on the Bambu Lab X1. At its maximum, it only opens to about 110 degrees, and if you accidentally bump into it, there's a risk of breaking it. 3. The spool holders are the same as those on the Bambu Lab A1, which means they aren't compatible with many filament spools, such as those from Prusa, Sunlu, or other brands with smaller or larger center holes. In those cases, you'll need to use an external spool holder or a filament dryer, which is less convenient and takes up more table space. 4. The nozzle wiping motion is too aggressive. As you can see, after my tests, the wiper for toolhead 1 is already worn out, since that toolhead was used more than the others. If it continues brushing the nozzle this aggressively, I'm not sure how long the wipers will last, and you may need to replace them more frequently than on other printers. 5. There are some incomplete features on my test machine. The auto-filament feeding only works during the setup wizard, and I was never able to get it to function when changing filament after the initial setup. Even in the setup wizard, it only feeds the filament partway in, not all the way to the nozzle to heat up and extrude. The time-lapse feature is also incomplete. I couldn't find where the files were stored, or even confirm if the videos were recorded. In addition, the camera doesn't work in the fluid web interface, although it does work in the slicer. 6. Some firmware settings like Pressure Advance are not working well. From the tolerance test, the square side couldn't clear 0.075 millimeters, which is below average. The nozzle preheating during multi-material prints is also not very accurate. It often delays 3 to 5 seconds, and sometimes even more when printing PETG with TPU, bringing the toolhead change time up to 10 to 12 seconds. While printing PLA, it's mostly fine, with toolhead changes taking about 6 to 8 seconds from one head stopping to the next starting, which is still pretty fast. In conclusion, should you back this project? My answer is a definite yes. A multi-toolhead machine like the Prusa XL or the SnapMaker U1 is far better than any AMS-style cut-and-purge system for multi-filament printing. The U1 costs only a fraction of the Prusa XL, and it's also cheaper than Bambu Lab's high-end machines. It makes multicolor and multi-material printing practical, faster, and most importantly, it doesn't waste more filament than the model itself. SnapMaker has told me they plan to include not only software upgrades, but also hardware upgrades in the final version. If that's the case, this could very likely become the #1 recommended printer on my list. Even with this 90% complete test unit, I can live with it, since the major features already work very well. Please also check out my website auroratechchannel.com, which tracks prices for popular 3D printers, laser engravers, and CNC machines. And if you're interested in the SnapMaker U1, I put the link to their Kickstarter page in the video description. Don't forget to do your own research and decide if Kickstarter is right for you. It comes with longer waiting times, and unlike in-stock machines, there can be more risks and uncertainties. Also, be sure to check the shipping cost. For the US, UK, and EU, it's an extra $50, and it may be higher for other countries. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.